How do endothermic reactions absorb heat? Imagine a reaction that feels cold to the touch or a substance that cools down when it melts. Have you ever wondered what makes these processes absorb heat instead of releasing it? Well, the secret lies in how chemical reactions and physical changes use energy. When a chemical reaction is endothermic, it means it needs to take in energy from its surroundings to happen. This energy is mainly in the form of heat. In these reactions, the energy needed to break the bonds between atoms in the reactants is greater than the energy released when new bonds form in the products. Think of it like needing more effort to pull apart a tightly woven fabric than the energy you get when you sew it back together. Because more energy is required to break bonds than is released, the system must draw heat from outside sources to keep going. This process causes the surroundings to lose heat, which is why things like ice melting or a cold pack feeling cold are examples of endothermic reactions. At the molecular level, heat energy from the environment moves into the reaction system. This energy helps molecules overcome the activation energy, which is the minimum amount of energy needed to start the reaction. Once the bonds in the reactants are broken, the absorbed energy gets stored in the new bonds that form in the products. This means the overall energy of the system increases, and the change in enthalpy, which is a measure of heat content, is positive. This heat absorption process explains why endothermic reactions often make the surroundings cooler. For example, when you use a chemical cold pack, it absorbs heat from your skin, making it feel cold. Physical changes like melting ice also absorb heat because the energy breaks the forces holding the molecules in a solid state without changing what the molecules are. In everyday life, understanding how heat is absorbed helps explain why evaporation cools your skin or how plants use sunlight to power photosynthesis. Photosynthesis is a complex process where light energy is converted into chemical energy, and it requires energy input, making it an endothermic process. So, in simple terms, endothermic reactions absorb heat because they need energy to break bonds and create new substances. They pull that energy from their surroundings, which increases the system's internal energy. This fundamental idea connects chemistry to many natural processes and everyday experiences, showing how energy flow shapes the world around us.